Hello, pre-calculus students, and welcome to our continuing lesson on real zeros of higher order polynomials. In the last video, we talked about finding a remainder using polynomial division. Now we want to talk about the remainder theorem, which says when f of x is divided by x minus k, the remainder is f of k. In other words, if you want to know if you want to take the polynomial divided by some other expression and get the remainder, well, there's a quick way to do that. You just plug in this k into the f of x function. Now, a couple major caveats here. One thing I want you to note here is that the coefficient is 1 and the power is 1. Okay? So it does not work. Okay? Only works if the coefficient and power are both 1. If either of these things is not true, then you cannot use the remainder theorem. If either of these things are not true, you cannot use the remainder theorem. So if you look at the previous example, you can see here the coefficient is 3, so there's no way that we could have used the remainder theorem for this previous problem. You just have to do the long division. The power is 1, but the leading term here, the leading coefficient, is not 1, so there's really no way that you could have done that problem using the remainder theorem. But here, let's look at a couple other examples where the remainder theorem may apply. So let's check this out. So I have f of x equals 3x squared plus 7x minus 20. G of x equals x minus 2. So find the remainder of f of x over g of x. Well, this term here, we can treat it as k, and we can apply the remainder theorem and just say that the remainder is just going to be f of k, which in this case is f of 2. And so you're just taking 2 and substitute it into this expression. Okay, so this is going to be 3 times 2 squared plus 7 times 2 minus 20. And that is going to give us 6. Okay. So this here is the remainder. All right. Now, we could have done the exact same thing. We could have gotten the same exact answer going through the same process as the polynomial division here. But because the two conditions are satisfied, the coefficient is 1, the power is 1, then we can apply the theorem. Okay, let's look at the next example. Find the remainder of f of x over h of x. And at this point, I highly recommend that you hit the pause button, try doing this on your own. You may even make a mistake, you may even get it wrong. But if you try it on your own first and then watch the rest of this, I think it'll help you to remember and learn this a little bit more. Okay, so hopefully you tried it now, and we're going to do this problem here. F of x divided by h of x, what's the remainder? And we got to be careful. The theorem has this form x minus k. Here we have x plus something, so we need to rewrite it as x minus k. So x minus negative 4. Okay, that's the same thing as this. So this tells us that k equals negative 4, okay, not 4. Okay. So to find this remainder here, we do f of negative 4. This is 3 times negative 4 squared plus 7 times negative 4 minus 20, which in this case gives us 0. And so there you have it. This is a quick way of finding the remainder. Now, one of the nice things about this is that if the remainder is 0, remember what we wrote up here, if the remainder is 0, then this expression is a factor. Okay? So we can say this, since f of x over h of x has a remainder of 0, h of x is a factor of f of x. Meaning that you can rewrite this function here, f of x is equal to x plus 4 times something. F of x used to be this big expression here. We know that we can pull an x plus 4 out of it, and whatever is left in here has to be able to multiply back to give you 3x squared plus 7x minus 20. So in the next video, we're going to explore how to get this expression here. Now we know a quick way to determine the remainder using the remainder theorem, and that tells us that this is a factor. Now we don't know the other factor, so we'll pick that up in the next video.